we need to find the point xy on the graph of y equals square root x nearest the point 4, 0. So that very concise optimization question is asking us to minimize the distance between the point xy on the function given and the point 4, 0. So we're going to let L be the length of the line segment from that point to the point 4, 0. And we have a diagram here. So in our diagram, I've sketched y equals square root x, and then I've connected with a line segment the point 4, 0 to our function. And the point where the line segment connects to the function would be the point x comma square root x. And we need to figure out the length of that line segment now. So the length of the line segment can be given by our length formula, and we can replace x2 and y2 with 4 and 0, the point given in the question. Now, thinking about some restrictions on these variables, it makes sense that the length of the line segment can't be less than 0, and it's probably not going to be greater than 4 because we know that the length of the line segment along the bottom here is 4. So if we're going to have a different answer, it better be smaller than 4. But in terms of where the x point is on our line segment, it could be anywhere from 0 to infinity. Although some thinking about this pretty much tells us it's not going to be that much larger than the number 4, because you can see the length of line segments are going to get quite large, but algebraically it could be anywhere between 0 and infinity. So we're going to use that information to eliminate our y value in our length formula by replacing y with the square root of x and simplifying. And then we're going to take this length equation and find the derivative of it. Fortunately, when we find the derivative of this function, the entire first part becomes the denominator, and then the derivative of the inside part becomes the numerator, giving us one giant fraction. So we know that when we have one fraction with a numerator over a denominator, the numerator is what's going to give us a solution of 0. So when we let L prime equal to 0, we get a very simple linear equation. 0 equals 2x minus 8 plus 1. Solve for x, we get 7 over 2. So now we need to check and see if this is actually a minimum. So we're using our chart. X goes between 0 and infinity, and then we're testing the number 7 over 2. So I substituted the number 1 into my derivative equation, and I got a negative value. Then I substituted the number 4 into my derivative and got a positive, verifying that 7 over 2 is indeed a minimum value. So if x equals 7 over 2 and y equals the square root of 7 over 2, then the length is square root of 15 over 2, and that length is the shortest possible distance from the point to the function.